Okay, so ongoing series on establishing trigonometric identities. I want to remind you again that when we're establishing trigonometric identities, they're almost always left-hand proofs. That is to say, you can only manipulate the left-hand side of the equation, and you're supposed to leave the right-hand side of the equation alone. So let's see if we can't make that work. So I guess the first thing I'm going to do here is I see this is over. I guess I'm going to do this. I'm going to get this 1 over sine u minus, and cotan is cosine u, isn't it? Over sine u. And remember, I'm just going to rewrite the other side, but I can't manipulate that side. So this is what we have now. I'm going to go ahead, these have like denominators, so I'm going to go ahead and put this together and get 1 minus cosine u over sine u. I did not do this problem in advance, so I apologize. Sine u over 1 plus, oh, I see it, cosine u. What this is, when you see something like this, if you notice this numerator here and this denominator here, the relationship they have to each other is that they're conjugates. So this is kind of a hint for you. So what I'm going to do here is this. On the left-hand side, I'm going to multiply by 1 using the conjugate of this. So I'm going to take my 1 over cosine u over sine u times the conjugate, which is 1 plus cosine u over 1 plus cosine u. Remember, it has to still equal this right-hand side. So I didn't touch that. So as we go through, when we multiply this, check this out, we get this times this. This is difference of squares. We're going to get 1 minus cosine squared u all over sine u 1 plus cosine u. Has to equal that same crap over here, doesn't it? 1 plus cosine u. And again, I'm going to just go through this a little bit more. And if you look at this, 1 minus cosine squared u has a Pythagorean identity, and its Pythagorean identity is sine squared u all over sine u. And if you can see, this is going to cancel out, isn't it? 1 plus cosine u equals sine u 1 plus cosine u, right? That gets us to here. And as we look at this, this cancels, doesn't it? Sine squared u over u is sine u. The sine u at the bottom cancels out, and we get 1 plus cosine u, and they are indeed equal to each other. All right? Not super easy stuff, but very doable. Let me see if there's one more. Let's do this last problem and see if we can get somewhere with this. Here, what I'm going to do here is I'm going to look at the right-hand side. Remember, we can't touch this, but I'm going to look at it, and this side is in terms of cosine. This side is in terms of cosine and sine. So what I'm going to do is I'm going to try to get this whole left-hand side in terms of the left-hand side, which is cosine. So I'm going to get 3, and we know that sine squared u is the same as 1 minus cosine squared theta, plus 4 cosine squared theta is equal to this bit over here, isn't it? 9 squared theta. Now all I'm going to do is this. I'm just going to do some algebra here. And the algebra I'm going to do is I'm just going to distribute this to here and here. 3 times 1 is 3. 3 times negative cosine squared theta is negative 3 cosine squared theta plus 4 cosine squared theta is equal to 3 plus cosine squared theta. And I believe it is, because we have 4 cosine squared thetas here minus 3 cosine squared thetas here, which gives us 1 cosine squared theta. So 3 minus cosine squared theta is in fact equal to 3 plus cosine squared theta. All right, if you haven't already subscribed, please do, and thanks for watching. Comments are always welcome. Thanks, you guys.